So hey guys, welcome back to another quick tutorial in the series of Core to Advanced Java for Automation Engineers. So I recommend you guys to visit my YouTube channel Pro Estate with AJ and click on subscribe button so that you will be stayed tuned for all upcoming tutorials. Okay, so in this tutorial we will quickly see the remaining details of JDK. For that, I'll open up this internal architecture of JDK once again. And let's see the various components involved here in this JDK architecture. Okay. So first block is Java application, then compiler, then here we have JRE, method area, heap area, stack area, PC counter, program register, native method stack and interpreter and JIT native method area interface. Okay. So Java application is your user interface where you are actually writing a code and storing the file into with a Java extension, right? This Java extension file with a Java extension is given as an input to the compiler. Compiler we have seen the role of compiler here is to convert the Java file into a bytecode, right? So Java compiler is used for that purpose. If you come back, your Java bytecode is provided to this runtime area, which consists of those 5 blocks. Okay, so method area is used for storing all the class code and method code. Okay, so all the classes bytecodes is loaded and stored in this runtime area. Okay, and all static variables are created in this particular method area, right? Next is heap area. Heap area is used for storing all objects that are created. It is also a main memory of JVM. All objects of classes like non-static variables are created in this runtime area. Okay, this heap memory can be expanded by its own depending upon the object creation, and this particular method area and heap area are actually shareable memory areas, right? Next is Java stack area. Okay, this Java stack area can be used for storing the information of methods that is under execution. Okay, and Java stack can be considered as a combination of stack frames where every frame will contain statistics of single method, right? This particular stack area by default in JVM creates two threads. One is main thread and other is garbage collection thread, right? Main method is actually a default method or entry point method for any Java program. And as you know, Java program starts with a main method. And second is garbage collection. It is responsible for cleaning up of all unused objects from heap area, right? So that's the purpose of this stack. Next is program counter register. So program counter register is actually points to the address where the next instruction which is to be executed is stored, right? And native method stack is nothing but our Java native stack area, which is used for storing non-Java code. Okay, so non-Java code is stored in this native stack. Next is interpreter. Now coming back to this interpreter, JVM performs this interpretation and bytecode is converted into a machine code in this interpreter, right? So at the end of the day, what you will get from this runtime area and interpreter is the output or the execution output. So whatever function you are trying to perform, right? You will be returned with that function. You will see the output in console, right? You will perform the operations and you will see the results as output of this whole process. Now coming to objects, class and method. A lot of times you might have heard from me that objects are created, classes are created, right? What are exactly those? I'll try to elaborate this with one analogy of cars. Here the car is the class, okay, and inside that car as an object we have different objects like Ford, Tesla, Toyota. Those are the objects of car, okay, and those will also have the attributes, something like color, horsepower will be the attribute of that particular object. Those objects will also have the behaviors, okay, behavior of braking, behavior of driving, right? So those attributes are variables and the behaviors are our methods. Cool. Okay, so method is like a function which is used to expose the behavior of object. Cool. Now next comes the syntax part of our program. Okay, for that I'll just reopen the document that we have created last time. I'll probably open with notepad, right? So here you can see we have defined the class. You can just note that class name is always written in let's say Pascal case. Okay, so first letter of class should always be a capital letter. That has to be a Pascal case. So there are two types of cases like Pascal convention and camel case, right? So Pascal case is written in this way, and camel case is written in this way, right? So for defining class, we will use Pascal case. So this way we can define the class. Then comes public static void main. Okay, so basically this Java main method is the entry point, as I mentioned, of any Java program. Its syntax is very common, like is always a public static void method. You can only change the name of string array, okay, and for example like args, here arg stands for arguments. You can give your own name here, like something like my string arguments, something like that, right? So rest of the things will remain common, so you just have to like by heart this syntax to start the Java program, since it is an entry point. Next comes this public keyword, okay. So this is access modifier of main method, okay. So it has to be a public so that Java runtime can execute this method. Remember that if you make any method non-public, then it's not allowed to be executed by any program. So there are some access restrictions applied here if you make it non-public. So this public means that main method has always required to be a public one. So it can be accessed from anywhere from the project. Next is static. Okay. Next keyword is static. So when Java runtime starts, there is no object of class present, right? So that's why the main method has always this static keyword. This always has to be there as a static keyword, right? And this main method has to be a static. So JVM can load the class into memory and call the main method. If main method don't have this static keyword, what will happen? If we don't have this static keyword, what will happen? This JVM would not be able to call it because there is no object of the class present in it, right? So that's why we always need this static keyword in main method. Next is void. Void means a Java programming mandatorily expect that it should return something, right? So Java main method doesn't return actually anything. That's why we want to define this void here, right? That's why its return type is void. If it is not written, you have to return something. If it is not mentioned here, if it is not a void method, then you have to return something, right? This has been done to keep the things simple, because once the main method is finished executing, Java program terminates. That's it, right? So there is no point in returning anything. There is nothing that can be done for the returned object by JVM. If we are trying to return something from main method, it will give compilation error as an unexpected return value. You can try that out as well, right? Next is string args. What does it mean? So string args is Java main method accepts only a single argument of type string array. So this is also called as a Java command line argument, right? So these are all about the syntaxes. Later you can open up parenthesis. Inside that you can write your main program, then you can close the parenthesis, right? That's how the syntaxes are defined. We will discuss those public, static, void keywords along with different types of keywords in upcoming tutorials. Stay tuned guys. Bye bye.